Greetings, engineering students. We are viewing Mr. Shelembe from Umgungundlovu TVET College. I will be doing mathematics and 6. Today, we are going to be looking at a formula sheet. Okay, so the formula sheet is important that you know where to find stuff, because when you are writing for your exam paper, it's going to be short in terms of time. Okay, so you need to know where to find things. You need to know how to manipulate things in your formula sheet. Okay, that's the most important part. So I'm having my formula sheet here. I will start with page 1. It has 7 pages. I hope this will assist you. So the first one that we are looking at is trigonometry. In N6, we know there is no section of trigonometry, but we apply a lot of trigonometry. That's why you learn a lot of it in N4, okay? So the first one that we are looking at a square identities. There are the 3 square identities. But the one that I'm interested in is this one, which say sine squared x plus cos squared x is equal to 1. That's the one that I'm interested in. This, we can manipulate it. We can make sine squared a subject of the formula. So we'll have sine squared x, which is going to equal to 1 minus cos squared x. You have seen that in N4 when we are dealing with the square identities. We can manipulate it as well to have cos square x, which is going to be equal to 1 minus sine squared x. Okay, let me just write neatly there. So it's 1 minus sine squared x. So these two, as you have seen, they are the child of the square identity of sine squared x plus cos squared x, which is equal to 1. Okay. The other 2 square identities, we also use them. Okay, no problem. But another one that I want us to look at is these double angles. Okay. So we have a double angle of sine, we have a double angle of cos. But if you look at the double angle of cos that we are having here, it's only have one equation, okay? Where we know in N4 that this can have more than one solution, okay, to it. So the other 2, I'm going to write them because they affect these 2 identities which are written here. So we have cos of 2a, which is equal to 1 minus 2 sine squared a. So we have another one which is cos 2a, which is equal to 2 cos squared a minus 1. Okay, so these are the square identities that we are having. So that will be your 2 cos. Okay, so these one, they can be manipulated. If you look at these 2, we have sine squared, which is not the same as this one of the square identity. We also have cos squared a, which is not the same as this one of the square identities. How did they arrive to that? In this first one, they made sine squared a subject of the formula. So if you take this to that side, you are going to get positive 2 sine squared a. Then you take cos 2a to the other side, then you are going to get 1 minus cos 2a, okay? Then you divide by 2, you divide by 2, you divide by 2. When you do that, you are going to be left with sine squared a, which is equal to 1 over 2 minus cos 2a divided by 2. Remember that 2 cannot divide that 2 because the other one is an angle, the other one is not an angle, okay? Then they manipulated also to get this one, so they made this cos squared a subject of the formula. By taking this minus 1 to the other side, then you are going to be left with 2 cos squared a on this side, which is going to equal to positive 1 because it was negative, plus cos 2a. Thereafter, they divided by 2 like we have done in the first one, so you divide everything by 2. So once you divide this by 2, you are going to be left with cos squared a, which is equal to 1 over 2 plus cos 2a, all divided by 2. So that's how we got these ones, okay? And then at the bottom here, we have a quotient identity for tan. which is tan x, which is equal to sine x divided by cos x. We also know, according to N4, there is another one for cot x, which is equal to cos x all divided by sine x. So this one is also important. It's not in your formula sheet, but you need to know it. Okay, so the next one is page 2. Okay, in page 2 to page 4, you are given now the table. This table has an f at x, which is here. It has the derivative of f at x here. It has the integral of f at x here. So when you move from this column to that column, what you are doing differentiation. Every time when you move from column number 1 to column number 2, you are doing your differentiation. Now, when you are moving from this column now to the last column, okay, we can see there you are doing your integrals. So you are doing integration. It's important for you to know this part because not everything you are going to know off by head. So you need to refer to your formula sheet. Also, if we are moving from the second column, okay, if we are moving from the second column to the first column, again, we are doing integration. So as we are moving from this column to that column, we are also doing integration. You will see this will apply a lot as we go along, okay? That is your page 2 of your formula sheet. You can see also there is a cot AX. This is the derivative. So if we are moving from there to there, you are differentiating. But when you are moving from there to there, you are going to integrate. You will see when we are doing examples in question 4 that there is a part of integral that you need to know from here to there. Okay? So the next part, which is page 3, again it's continuing. Okay? What is noted though, for what you need to note, in N4 and N5, we didn't give you the derivative of the arc function in N4. We only gave you in N5, so they are continuing now in N6. Now in N5, the derivative of the square identity was not given because you needed to know how to apply it using your N5 knowledge. But in N6, you don't have to work it out. You just take it from the formula sheet. There is the integral of sine squared AX. This is the answer, okay? So you don't need to go and do partial differentiation for this. So you just go in straight and get it straight here, okay? Or differentiate integral by parts. Then there is also page 4 of your formula sheet, which is continuing. But now page 4, the table ends here, okay? You need to be careful because most of the learners, they can't find the integral of cot square AX because they're looking at the previous page, but we know it's in page 4. So that's why you need to be familiar with your formula sheet. Then we have another one where we are looking at a function and its derivative, okay? So which is this going to be its answer? Then we are having a derivative divided by the function, which is given here. We are going to be using a lot of this in question 2, okay? When you are dealing with question 2. Then there is this part, which I like to call it inspection, okay? So this one is inspection. So if you are integrating with using inspection, this is what you are going to be using. You need to be familiar with it. You need to know how to look at it if you are looking for your formulas, okay? Because some of the integrals, you don't need to waste time. They are prescribed to you in this one, which we call the inspection. And then here, that's where we start now, calculation of area. So you are going to be calculating area. This first one is if you are having only one graph, okay? This one is if you are having 2 graphs. That is now your question 5. So you need to know where to find your formulas. This one is say if you have an area with the rotation of x, which is going to be the integral of a to b of y dx, okay? Then you have, again, area with the rotation of x, but now with 2 equations. You are making y a subject of the formula here, okay? If you are rotating with y, that means now you are making x a subject of the formula. Okay? If you are rotating with x, you are making y a subject of the formula. If you are rotating with y, you are making x a subject of the formula. Again, this is if you are having one equation. This one is if you are having two equations. Okay? I hope this will assist you as you start to do question 5. Okay? Then there is for volumes, because the other one was area. Now we are looking at the volumes. Now with the volume, we have a volume with a rotation of x. Something that is new now from the area is that now we are having pi. If you look here, we are having pi. Okay? So that's something that is new if you look at the volume. Then we square our equation. In the area, we were not squaring our equation. Now we are squaring our equation. So we are having y squared. Because we are going to make y a subject of the formula, we have a rotation of x. Then the same below, if we have a rotation of y, you will have pi integral of a to b of x squared. Now we are squaring the x, which we have made a subject of the formula. Okay? Go to the next column, because these are different equations. Okay? So going to the next column now, this is if you're having two equations. This was one equation, now we are having two equations, okay, which will end here. So if you're having two equations, this is the one that we are going to be using. Now, again, just like when we were looking at the area, now we are having y squared 1 minus y squared 2, because we are still working with two equations in this instance. And then the last column, it is using what we call the shell method. Okay? Shell method, you are going to use it if we are told to use the shell method, or you can see that your strip is failing. Then you need to use shell method. But more of this will be in question 5 when we are dealing with the volumes. Okay? Then we have area moments here, which we find here. Okay? We have centroid, which we are going to be using our area moment. Then we have a second area moment, which is found on the same page. Then we have volume moments. Okay? Then we have a center of gravity. All of this is under question 5, which we are going to be doing not so long. Then we have moments of inertia, which you're supposed to know. Then we have general. Then we also have a center of fluid pressure, which we are going to be calculating still in question 5. So this will still be in question 5. So this one is like hidden here. So don't make sure that you know how to find it. Then we have for question 3. So all of these ones are for question 3. Okay? This is partial integrals when we are dealing with the partial integrals. So we have the first one here where it's repeating itself. We have another one where we have more than one factor that is repeating itself. Then lastly, we have another one which has some binomial into it. Okay? Then we have question 6. All of these belong to question 6, where we're calculating the area of the arc length, where when we're having a rotation of x, when we're having a rotation of y as well. Okay? So that is your question 6. Then we have also the continuation of question 6. So all of this, now calculating also the arc length, that's question 6. Okay? Then we have question 7. This one is for the first order differentiation questions. Okay? So you will see when we are doing the second session, we are going to be using this formula. Okay? This is the only formula for question 4.1. Then we have another ones for question 4.2, which starts here and end here. These equations are for your complementary functions in question 4. So all from here to there, we are dealing with question 4. So you need to know where to find your information. Okay? Lastly, we are having the last one, which is for question 1. You can see there's only one equation because majority of them you have done in N5. That's why they only put it for one equation for question 1. Learners, please make sure you know where to find stuff in your formula sheet. Okay? In your examination, you can even take off the pages of your formula sheet. Okay? Just like I have done here, you can see I've taken the pages off so that you can easily reference when you want to reference to your formula sheet. Okay? Because it will be a short time, 3 hours. If you are going to waste time looking for formulas, you are going to stuck. You are not going to finish your examination. In order to finish your examination, you need to know these formulas. Okay, learners, now we have seen our formula sheet. Now this is question 4, okay, which I was talking about. Question 4 in some of the textbook, you will find it's chapter 10, okay. So we are dealing with first order differentiation and second order differentiation. But for now, I'm going to be looking at the first order differentiation, okay. Now this formula that we have spoken about, which I said you find it in page 7. There it is, it's coming back again, okay. You can see this formula is in your formula sheet, it's under page 7. But these notes are not there, so you need to know them now, okay. Now these notes, you are going to get an equation, which obviously will have a left-hand side and the right-hand side. They will say find the general solution or find the particular solution. Let us focus on the general solution for now, okay. It says here on the notes, you need to ensure that your dy over dx and y are on the same side, okay. So whatever that does not contain y or dy over dx, put it on the other side, okay. Preferable, your left-hand side. On your right-hand side, you are only going to have something, a term with dy over dx, a term with y. It doesn't matter what else is there, but as long as that term has y or the term has dy over dx. The next part, ensure that the coefficient of your dy over dx is equal to 1. So you want to make sure that your coefficient value for dy over dx is equal to 1. Okay? Then you assign your coefficient of y to be p. Okay? That coefficient is the one that you are going to integrate. You are going to find the integral of p, where it's integral of p dx. So whatever the value that you are having, you are going to find the integral of it. Then the next part, it's say, add or assign the other side, which does not have dy over dx and y, to be q. So we are making that side to be q, okay? Then you substitute all of the above information into this equation. Once you have done that, you can now integrate this part. Particular solution. You take your general solution, which you have written here or calculated here. You substitute the value of y and the value of x to find your particular solution. Thereafter, you solve for the value of c. Okay? Let us see if we do one example, what will happen. This is how the question is going to be phrased. To say determine the particular solution. In this particular instance, we are looking at a particular solution. We are not looking at a general solution. Okay? So, we are having x dy over dx minus 2y minus 3x cubed plus 5x squared, which is equal to 0. Then we are given the coordinate that we are having x equal to 2 and y equal to 1. These are coordinates now. We are going to see because we are going to substitute them once we find our general solution. Okay? Now let us find our general solution. It says the first step, make sure that you only have dy over dx and y on the same side. So we are having, in this instance, x dy over dx minus 2y, okay? Whatever that does not have y now, let us take it to the right-hand side. So we have that minus 3x cubed, so we take it to the right-hand side, which is going to be 3x cubed, which is going to be positive. Then we have plus 5x squared, which is going to be 5x squared, which is going to be negative on this side. okay? Once you have done that, the next step is say, make sure dy over dx, the coefficient is 1. That means we need to divide with that x in this instance, okay? So when we are dividing with that x now, we are going to be left with dy over dx minus 2 divided by x multiplied by y, which is equal to, then on this side again we divide, so we'll be left with 3x squared minus 5x. So that's what we are left with, okay? You can see also here I'm trying to think of a next step, okay? That's why I'm separating the y so that I can see the coefficient. We said we are going to say let p equal to the coefficient of y. My coefficient of y is minus 2 divided by x. It's not only 2 divided by x, include the sign, okay? Then we want to find out the integral of this p. So we are looking at the integral of p dx, which is going to be the integral of minus 2 all divided by x dx, okay? Then we look at the integrals that we have been doing in n4 or n5. So this is going to be minus 2 ln x, okay? It says whatever that is on the right-hand side which does not contain x or y, let it be equal to q. So our q in this instance is going to be 3x squared minus 5x, okay? So that is the value of our q. Now let's go to the next page so that we can work this out nicely. It says there, you have a formula that we have been looking at, which is y times e to the exponent integral of p dx, which is equal to the integral of q times e to the exponent integral p dx dx. This is in your formula sheet, okay? Now we need to substitute whatever information that we are having. So we have y multiplied by e, then we have the integral of p dx, which we calculated here to be minus 2 ln x, okay? My pen is continuing now. Let me stop my pen there. Okay, sorry about that. Okay, so we have our ln x here, which is going to equal to the integral, the value of q. We need to put it in the bracket because it's more than one term. So therefore it will be 3x squared minus 5x, we close that, multiplied by e to the exponent, the integral of p dx, which is minus ln x, okay, dx. Then we can remember, in n5, you dealt with if we are having a to the exponent of log of function f at x, base a, all of this is going to equal to f at x, okay? So that's what it's going to be equal to. So now here, but we can't yet apply it because we still have that minus 2. So we need to get rid of this minus 2 first. So we are going to have y times e to the exponent of ln of x to the exponent minus 2. So we raise the minus 2 to be an exponent. Then we are going to have the integral. Again here, we still have our 3x squared minus 5x. Then we have e to the exponent, there is a 2 here, of ln x to the exponent minus 2 dx, okay? And then we are going to apply this exponential law. So we are going to have y times 1 divided by x squared, which is going to equal to the integral of 3x squared minus 5x multiplied by 1 divided by x to the exponent square. Then we can still simplify this now, okay, by multiplying inside. So we are going to have y all divided by x squared, which is equal to the integral. If we multiply here, we are going to be left with 3. If we multiply here, we are going to be left with 5 divided by x, okay, dx. Then we integrate, because now it's easy to integrate this part. So if we're looking at the integral here, we are going to have 3x. We are looking at the integral here, which is going to be 5 ln x plus the c. So this becomes now your general solution, okay? Once we have this general solution, which we are having here, So that's your general solution. You can find the particular solution by substituting these values there. Remember, we said that our x is equal to 2, our y is equal to 1. That's what we are given at the top there, okay? So we are having y, we are going to substitute 1. For x squared, we are going to get 2 there squared, which is going to equal to 3 multiplied by 2 minus 5 ln of 2 plus c. Okay? Now all we need to do, we need to calculate now the value of c. So c is going to equal to 6. So c is going to equal to the half, 1 over 4 that we are having on this side, minus the 6 plus 5 ln 2. That's the value of c. Now all we need to do is to press our calculators so that we can find the value of c. Okay? Let us press our calculators. My calculator, I've put it on the phone for now because I'm doing the live calculations here. So what we are having 1 over 4, so you put 1 divided by 4. Then we are having plus 6, minus 6, actually, not a plus. And then we are having a plus 5 ln 2, okay? We are going to find that the value of c now that we have calculated is going to be minus 2,284, okay? So that's the value of c. Now you need to rewrite this so that you have your particular solution. So your particular solution is y divided by x squared. We are not putting the values of y and x here, equal to 3x minus 5. Okay, so we have minus 5 ln x, okay, which is what we are having here. Now we have that plus c. Now we don't want that plus c anymore. But what we want now to put the value of minus c. That's why we are having what we call the particular integral in this, the particular solution for our differentiation. Now we have worked out this, we can do more calculations, but for you, you can now try to do this one so that in the next session, when I'm doing the second order, I will start by solving this one, okay? Practice it at home. This one only wants you to calculate the general solution, not a particular solution, because we are not given the coordinate of x and the coordinates of y. So we only want a general solution. Practice more in your question papers so that you will know how to calculate. Okay, for further questions, you can email me at kingswaley@gmail.com. College website will be running as well, and the Department of Higher Education website where these notes are going to be uploaded, okay? But for personal contact, please make sure that when you are sending, your heading supposed to say Mathematics N6 question. Then I will be sure to answer you. Thank you very much.